Think math.
We overlay histograms of heights for year 1 and year 3. In year 3's bars are taller in every single class, more of them in every interval. That cannot be right. Year 3 has 200 students and year 1 has 50. What is this picture actually comparing? What it compares is not height. It is headcount. A frequency carries how many, so 4 times the people means roughly 4 times the bar. Overlay them and the bigger group wins in every class. Whether the shapes differ at all is invisible in this picture. Something worse can happen too. 40 students in year 3 are at least 170 tall against 15 in year 1. The bar for year 3 towers over it. But as a share, year 3 is 40 out of 200, not 0.2, and year 1 is 15 out of 50, not 0.3. Year 1 is ahead. The bars had it exactly backwards. The fix is to change the vertical axis. Put relative frequency up the side instead of frequency, and both groups have their whole set to 1. 200 becomes 1. 50 becomes 1. Size has been erased, so all that is left is how each group shared that 1 out. Which is to say, the shape. Now, overlaying them actually tells you something. Which group leans to the right, which is more evenly spread, all of it reads straight off. The 2 graphs even enclose the same area, since each of them shares out 1. Only with size erased can shapes be compared. So frequency carries size, and overlaying it sets sizes fighting each other. Relative frequency has that size taken out, which lets 2 groups be measured with the same ruler. Next time, where a relative frequency heads as an experiment is repeated. See you in the next one. A sip of math every day, here at Think Math.